Hey, welcome to Futureproof Your Planet, our sustainability mini-series. I'm Esther, I'm a second-year physics student, and I'll be your host. This series will be going on different ways we can be sustainable in different subjects, like computer science, fashion, engineering. Today I'm joined by Dr. Riza.
Hi everyone, good afternoon.
She's going to be explaining to you in the video about how we can use AI to modify how we behave to reduce our carbon footprint.
Hi everyone, my name is Riza Batista-Navarro and I'm a senior lecturer in text mining at the Department of Computer Science at the University of Manchester. Today, I will be talking to you about how you can future-proof your planet by thinking, studying, and developing solutions based on computing and AI, which are aimed at helping achieve Sustainable Development Goals, or SDGs. In particular, SDG number 12, which is about sustainable consumption and production, and SDG number 13, which is climate action. Specifically, I will be describing to you a project that we worked on recently, which is essentially aimed at the development of AI solutions for increasing or enhancing the awareness and the agency of people when it comes to the carbon footprint of their food. I also want to put forward to you and to challenge you to essentially contribute to the discussion around carbon footprint and sustainability by thinking about solutions based on computing and AI. For instance, we can think about what other types of solutions can we develop which are aimed at enhancing sustainability, and importantly, how can we make computing itself sustainable? For example, when we develop and train our computational models, they also lead to carbon emissions. So how can we improve how we develop those models in order to be more lower carbon? You might wonder how a computer scientist like me started to work in this area of food consumption and sustainability. Let me take you back to autumn of 2020, basically when we had the COVID pandemic. I was drawn to a funding call from Nesta, which is a funding institution, and they had some interest in projects which are aimed at social impact using human and machine intelligence, or something that they call collective intelligence. Meanwhile, I was at home and I was thinking, this is a bit boring, I cannot go out, and other people also cannot go out and enjoy food outside as they used to. I myself started to look into online recipes, even if before the pandemic, I wasn't really that interested in cooking. I noticed that with these recipes, it is very common to have nutritional information, and that is good because that helps us to come up with healthier food choices. However, if I wanted to find out about the carbon footprint of a recipe that I'm intending to cook, then that is much more difficult to obtain that information. Carbon footprint is one of the metrics that is used to assess environmental impact. Essentially, if somebody wants to find out about the carbon footprint of a recipe, then they would have to use web form-based calculators. This would require inputting or entering information one by one for every ingredient in that recipe. And this can be tedious and time-consuming. As somebody whose research is focused on understanding natural language, the language that is used by humans, then I was interested in finding out what if machines can somehow automatically read and understand the content of these recipes and figure out what the carbon footprint of each of the ingredients would be and come up with an estimate of the carbon footprint for the entire recipe. In order to ask these questions, we decided to apply for the Nesta funding. The funding we received allowed us to work on a project called eCare, which is short for Emissions Calculator for Recipes. Although the word calculator is in the title of the project, what we did as part of our work actually goes beyond what a web form-based calculator does. In our approach, we made use of natural language processing, or NLP. These are techniques or methods which allow a machine to understand the content of a recipe document automatically. NLP is one of the areas within artificial intelligence, or AI, which is for enabling machines to understand and analyze documents or text written in natural language. Natural language is a type of language that we use as humans. And this is important because recipes are written in natural language. Although some recipes would follow a very high-level structure, for example, they would have a section for ingredients and then followed by instructions, sometimes what is actually contained within those sections could vary from one recipe to another. For example, a recipe that is written by a content creator or a blogger might have more verbose descriptions of the ingredients compared to the recipes which are contained in our standard recipe databases such as BBC Food. In the first stage of the eCare project, we invited participants to contribute to a survey where we asked them to give us a list of 5 recipes that they typically cook within a week. These recipes basically allowed us to create a data set of more than 500 documents, which supported the development and testing of our AI and natural language processing models. For example, we have a natural language processing model for automatically extracting or recognizing the mentions of ingredients within these recipes. And this is very important because one way in which we can identify or estimate the carbon footprint of a recipe is by determining what are the ingredients which are required by that recipe. In the next NLP step, which is called entity linking, we now have the mentions or the names of these ingredients, but our task is to try to look up or to find out in a database what is the exact carbon footprint or emissions corresponding to that ingredient. So how we do this is by developing an NLP model, which is essentially able to handle the variation and the ambiguity in the language that we use. This is important because sometimes we refer to the same things in different ways. For example, when we say pepper, we don't necessarily know if the person is referring to, let's say, red pepper or black pepper or some other type of pepper. Or if we find a recipe which mentions aubergine, this is something that can be understood by people who live in the UK, for example, but elsewhere, they might refer to the same thing as eggplants. Another tricky example might be the fact that what we call chips in the UK would be known as fries elsewhere. So with this method for entity linking, we are able to obtain information on the carbon footprint from a database, and this allows us to calculate the overall carbon footprint for a recipe in terms of what we know as kg/CO2e, or kilogram of carbon dioxide equivalent. This is the unit of measurement that is used to measure the carbon footprint or carbon emissions of anything, including food. So now that we have the results of AI and natural language processing, we develop in the next stage of the eCare project a graphical user interface for presenting these AI results to the user. How it works is that a user will be able to navigate to any web page that contains a recipe, click a button that will trigger the analysis of this recipe using the AI models, and then the result of the carbon footprint estimation will be displayed to them. This is done in the form of a badge, which is colored according to a traffic light scheme. For example, it will be shown in green if it is low carbon, amber if it is medium carbon, and red if it is high carbon. And this number will be expressed in kg/CO2e. Additionally, we also present some information in terms of how to interpret this number in terms of other daily tasks which we may be more familiar with. For example, watching TV for a certain number of hours or leaving the light bulb on. This helps users to understand what is the impact of carbon footprint in terms of other tasks that they are familiar with. Additionally, this Chrome browser extension that we developed, which is the graphical user interface that we implemented, allows people to find information on the specific ingredients in the recipe which can be considered as high carbon. If a specific ingredient occupies at least 20% of the carbon in that recipe, then we flag it up as high carbon. We also have an NLP tool which is responsible for suggesting an alternative or a substitution in order to make the overall carbon of that recipe much lower. The prototype Chrome browser extension that we developed was then distributed to the same participants that we engaged with in the first stage of the eCare project. The results of the comparison with and without the carbon footprint information provided by the plugin are actually quite encouraging. Without the plugin, more than 50% of the recipes that were chosen by our participants would correspond to recipes having between 2 and 20 kg/CO2e. However, with the use of the plugin and access to carbon footprint information, less than 25% of the recipes would be between 2 and 20 kg/CO2e. In fact, more than 75% of the recipes they chose only have a carbon footprint of less than 2 kg/CO2e. This resulted in a drastic drop of 81% in terms of the carbon footprint, which is quite substantial. As with any research project, the study that I just presented has some limitations. First of all, we were only able to engage more than 100 participants in our study. We could, for example, in future, conduct another study with much more participants to make our results more robust. Secondly, Our study based on the Chrome browser extension is based on the intention of participants in terms of what they plan or intend to cook within a week. And it is not at all based on whether they actually cooked what they said they would want to cook. And lastly, we also have to think about the tension between the fact that when we are developing AI models, as we did in this project, we are also, of course, producing carbon emissions in the development and training of those models. So we have to explore the question of whether it is worth developing those models using AI, considering that they have their own carbon emissions, in order to solve or to address a problem, which is also about lowering carbon footprint, although in a different sector, such as food. These are the sort of problems and issues that would be interesting to investigate if you are coming to study computer science at the University of Manchester. Coming back to the challenge that I set at the beginning, it would be useful for us to think about how we can make AI-based solutions or computing-based solutions for addressing sustainability challenges. At the same time, we should also think about how we can make computing itself more sustainable. I invite you to think about how you can turn your interests into ways or techniques which will help us in future-proofing your planet.
Hi, welcome back. We're going to start off with the questions you guys put forward. The first question I have is, do you believe technology is the only solution to sustainability, or do you think humans can still fail to achieve sustainability with the best innovations?
Very interesting question. I definitely think that we cannot just rely on technology in order to achieve sustainability. For example, if I just link it back to the tool or the methods and the AI models that I was talking about in the video, essentially the user of such tools still have to have the intention. They still need to want to eat sustainably or to become more lower carbon in their lifestyles. Without that intention, even with a nice tool, nothing is going to change. There will be no impact made. So essentially, if we were to achieve sustainability, definitely we need people to actually want to have that positive impact on the environment. So even with the fanciest technology, we can still fail, without the human intention.
Yeah, but did you find that people were more likely to make the more sustainable option when it was presented to them?
Yeah, that's actually one of the encouraging results from our study in the research. Because, well, first of all, we knew from previous studies that a lot of people, although many of us have kind of ingrained habits in kind of our preferences, a lot of people also have the intention to change. They do want to eat more sustainably. They do want to make a positive impact on the environment. But the problem is that they don't have the information at hand to make them to make the decisions which are kind of better food choices.
Yeah.
In practice. So that's why we developed the tool. We were very motivated to do that, to create the tool, because we thought, oh, this could potentially create an impact. When we developed the tool and we tested it, it was very encouraging to see that indeed there is a kind of, I would say, dramatic change. So without the tool, people were basically, we ran a survey, and a lot of the people were choosing recipes that they said that they will kind of cook in a week. 50% of those recipes have, let's just say, medium carbon, between 2 and 20 kg CO2e, which is the unit of measurement for carbon. But with the tool, essentially, more than 75% of the recipes are now lower carbon, basically having less than 2 kg CO2e. So that's kind of encouraging and positive, kind of, just to show us that even by just having the information in front of them, knowing that this recipe is lower carbon than another, people tended to choose the lower carbon option.
Yeah, perfect. Does AI pose a great threat or benefit in the world in the long run? And is there any way to make sure?
I'll answer that question by kind of, talking about AI more generally, not just AI in sustainability or the use of AI in the food domain. I think, unfortunately, nowadays, if we look around the world, if we read the news, unfortunately, we can see both the benefits and the threats of AI, right? So we can see how AI has been used to, to discover new medicines and improve healthcare. But at the same time, we also get worried about the proliferation of deepfakes and misinformation, disinformation, and sometimes those things are unfortunately generated using AI. So it's really hard to predict. I mean, I don't want to say, oh, for sure, this is what's going to happen. However, I do think that this kind of dilemma gives us a good opportunity in terms of like us being scholars or researchers, and especially students who will become the next generation computer scientists or researchers in AI. I think this kind of dilemma really puts forward a nice challenge and a nice opportunity for people to think about how do we develop AI systems or AI tools in a responsible way, in a way that the benefits are maximized and the threats are minimized. Because I think the problem that's been happening currently is that AI tools are being developed, and because of all the excitement around, oh, there's this new tech, there's this new fancy model and so on, sometimes we lose track of kind of, the ethics behind it. We lose track of how can this potentially negatively impact society. But I'm hoping that with the next generation students or AI researchers, if we bear in mind that every time we need to develop something which is related to AI, we need to think about how to do it in a responsible way or in an ethical way, then I feel more hopeful that eventually the benefits will outweigh the threats. So yeah. But hard to predict. I can't really predict.
Something further down the line. So people are asking, is the software public or available to the common man yet? And if so, what's the URL? Or where can people find it?
Oh, right. Okay. That's really nice. Thank you for the interest. I appreciate that. Yeah, it's definitely the app which you saw in the video that is available in the Google Play Store. It's still in kind of in development mode, but essentially if you're interested, I think we can come back to you with a link so that you can try it out. So it's not at production level. That's why it's not yet. I don't think if you go to Play Store and search for it, you will find it automatically or immediately rather. But we'll come back to you with the way so that you can download it. We'd be happy for you to try it actually and to get your feedback.
The next question is, does the carbon footprint of the food depend on where it's been eaten? Basically, like how it's been transported around the world.
Yeah, where it's been eaten. So I think maybe rather than where it's been eaten. So I'd answer the question by explaining a bit about the supply chain. So the food that we eat, like the food that we have in front of us, that basically there's a whole supply chain that's involved, going from the agriculture that went into it, right? And then how it was produced, how it was transported, and then finally in our homes, how we prepare it and how we cook it and so on. So this question about does it depend where it's eaten, I would say it depends where the ingredients came from. So for example, a lot of the carbon footprint comes from the transportation and the packaging, for example. So let's say if the ingredients came from kind of farther away, then the higher the carbon footprint. So it's more about the origin of the ingredients. Of course, there might also be a factor around where it's eaten, in the sense that if you are, let's say we're based in Manchester here, if we get our ingredients from our local shops and so on, so that is considered as more sustainable, yeah. And assuming that you consume that also in Manchester, then yeah, you're eating more sustainably, essentially. So yeah, I would say there definitely where it comes from is a factor in the carbon footprint of food.
Yeah, for sure. Is there any development that's going to be done so that the user can say where they're from, and so then it's more catered towards them?
I think the app right now is the challenge that we had in developing this app is that we are relying on some data sets, right? Essentially giving us information on what is the carbon footprint of the ingredients. But the data on the carbon footprint of these ingredients and where they came from specifically, that's very hard to find, and sometimes that's because of commercial reasons. So let's say not all supermarkets, for example, or retailers, they don't publish the data as to where they get their ingredients from, and so on. So then it's hard to keep track of those things. So in the app, we've had to kind of fall back to like averaged values. So for example, in the app, if it says beef has this much carbon footprint, that is not yet taking into account whether the beef comes from the UK or from elsewhere.
Yeah.
But to answer the question, hopefully in the near future, we intend to develop the app further so that we can incorporate this information about the origin of the ingredients, so that we can take into account exactly what I was saying earlier about how it varies depending on the origin of the ingredients, and also perhaps where you shop, So for example, there are now apps which say, okay, here's a recipe. Are you going to get these ingredients from Tesco, for example?
Yeah.
Or any other supermarkets around? Then that could also help in identifying whether, again, are you sourcing your ingredients more locally or elsewhere? So work in progress, let's put it that way. Yeah, but that's one of the future plans.
Yeah, I think that's probably about all time we have for questions.
Right.
So I just want to thank you all for joining our Master Series, and be sure to come to our other ones where we'll be talking about various other topics and how you can be sustainable and future-proof your planet.